see here. I guess I will let people show up a little bit. I'm gonna get some water. Let's see here. I'm pretty sure I'm the actual viewer. No, I have 0 viewers now, so all right. Anyway, we will have a very short stream because I have slept 4 hours last night. So we're just gonna kind of do a little bit of a thing, some very light programming, I would say, very high level stuff. And that's really about it. So for whoever might be watching this at some later point, the plan here is basically to be able to register handlers for a server structure that basically says, oh, we will route basically requests based on request data, path probably. We'll start out with path certainly. And then we will route that to different handlers, and these are functions that look a certain way and so on. So let's first say, what is a registered handler? Actually, let's invent this server structure first. So we have a server here, which is a struct. We could say that there's an allocator. I don't know that it's actually needed. We're gonna kind of leave that for now. We're gonna say handlers is actually a slice of a registered handler, like this. And a registered handler is going to be a struct with not a path, because we actually kind of want a function here. So I'm gonna actually say that we have a matcher, which is a proc that takes a request. Sure, HTTP request, it sounds good actually. I had kind of planned for this to just be a path, but let's actually do this, I think it's fine. And then we have a handler here, which is a proc that takes a request. Actually, it will take a socket, which is a net TCP socket, like this, and then a request. And probably, let's also say that this takes an allocator. I'm gonna, yeah, I think this will be fine. This is gonna take an allocator. And that's just sort of for, yeah, I think that's gonna be nice for just being very explicit. And I'm actually going to name this type handler here. And here we're gonna say handler is equal to this, right? And what we can do here, honestly, I don't know that it makes much of a difference, is just type like this. And here we're gonna name this a matcher. So a matcher is type and then this, right? Yeah. Okay, so now we have these registered handlers, we have a server here, and I want to basically have a function that adds a handler to a server. So add handler, let's say server register handler is a proc, takes a matcher, I want to say. I want to make this dynamic actually. So this is going to take a server first of all, which is a pointer to server, because we'll be changing this. And this is going to be a matcher, a handler, like this. And here we can sort of maybe say, let's say we take an allocator, which is just context allocator, right? And here we might actually want to say mem allocator error, right? This could be a reasonable thing to do. And here we're going to actually say append to server handlers, like this, registered handler with matcher equals matcher, and handler equals handler. Nothing super crazy there. Let's kind of see if this actually works out. We're going to do an or return. Here we can actually do append lm if we're really concerned with that. Here we're going to say return nil, because we in fact do not have any errors here. Because if we pass this line, we don't have any errors, right? So this can basically return an allocator error, and that's fine. We could also skip that, to be honest. It's kind of doesn't matter. Server get handler is what I want to do here. And here we have a server, which is we should be able to just say, you know, just a server. We don't need a pointer to it actually. And let's say request like this. This will return a handler, which is a handler, and okay, which is a bool. No, in fact, we could probably just say handler here. I want to say let's do that for now and see what actually happens here, right? So basically, what we're gonna do here is gonna say for age in server handlers like this. If a matcher on request is true, right? We want to return age handler like this. If this is not actually the case, we're going to return nil, right? Let's save that and see what's up. Yeah, no errors. This all seems kind of fine. That's kind of why I'm saying this is kind of high level, right? Essentially we're just writing Ruby or whatever it might be here, right? It's not really super low level fancy stuff, right? So we have these just to catch the two people up who just arrived. What we're doing is we're creating this server structure here with a bunch of handlers inside of it. So this is a dynamic array of registered handlers like this. And a register handler is a matcher together with a handler. And this matcher takes a request and says, I can handle that request, right? So true would be, yes, I can handle that. False would be, it's not for me, right? And basically what we're doing when we're registering a handler is just adding these together, right? And then when we get the handler, we basically say, hey, I have this request. Do you have a handler for me? We go through them one by one in order and just say, does this matcher here, which of course returns true or false, does that actually match the request we have, right? So that is basically the actual routing structure that we will have in this program. And we will try to fit that into, let's see. We need to modify the client state as well, right? So for those who might have seen the last episode, we actually have this thread state, right? And so what we actually want to do here is have a dynamic registered handler as well, right? And importantly, a dynamic array is really, it's really just sort of a pointer regardless. You might be thinking here now, hey, you have this as a value in your structure, but this value really represents a reference anyway. when I say reference, I don't mean anything like C++ necessarily. I mean just a pointer, right, to register handler. If we actually go to this, let's see if we can find this in Odin, right? So code Odin, and we can do RG, let's see, dynamic array, I want to say, something like this. Let's just open our editor. I don't know why I even bother with this usually. Let's see here, type info, dynamic array, raw dynamic array. This one will definitely give us what we want. So here you can see that this is a pointer to data. It has a length and a capacity and an allocator embedded in it. This is really what basically makes it different than a raw slice, right? But a raw slice is also a reference, right? We have this pointer to data, and then we have a length. Here we have that, plus we have an allocator that's embedded inside of the thing, and we also have a capacity. That's really it, right, in the end. Let's see here. Oof. Sorry if I am a little bit unfocused. I have had very little sleep last night, so I'm just kind of trying to power through this. So we have these handlers now. You fixed it. Okay, TCP accept. Really? Accept had an incorrect param. This is very strange. I mean, I've been using it for quite some time, but again, this could be all kinds of stuff, I guess, that could be weird. Oh, no, I've been using it. I don't, that's a little bit, that's disconcerting. But yes, this happens in Odin, right? It's a small community. Linux is not prioritized in the end, right? But yeah, I'm really happy that it was solved, because this is obviously, if you're writing servers and so on, you do want to be able to call TCP accept. It's a good function. Yeah, oh, you were on a previous version. I'm on the dev versions every month. So I switch basically the dev. Now we're on dev 2023. 11 is what I'm on. Obviously, I guess 12 has come out. So that's usually how I'm doing it. Actually, no. I just pulled from master, yeah. But I have been on master for quite some time, and I haven't had this issue, at least for months. But yeah, if you were on a previous version before that, then yeah, it was probably wrong. I fixed some DNS errors 4 months ago or something. 6 months ago maybe, and so on. So we had some stuff that was just pure garbage in the Linux side of networking and so on. We were also missing syscalls, like they were just plain missing. We are still missing epoll as a syscall. I added poll, but I think I'll be adding epoll as well. And we already have the syscall numbers for epoll in the code base, but we just don't have the actual calls and so on. Okay, yeah, I mean, this is good. Maybe it was a temporary fuck up, you know, maybe someone messed with it or something. That could be the case, I suppose. But yeah, this is just something that, yeah, it happens with Odin, obviously. So here we have the server register handler here. I think I called our thing this as well, right? We take a server here. We're gonna create a server, which is gonna be here. We're gonna start modifying this here, right? So we have a matcher here, and what we can do here is we could essentially say request HTTP. This is the most basic matcher you can have, right? We return a bool here. Here we could just say, sure, request.path equals this, right? And what I want to do with the result of this actually is say basically, this comma should not be there. I want to say handle welcome, because this is of course what we have from previous iterations here. Let's see if we can take that code and actually put it in a handler function. Because we have, what we're replacing here are these ifs, right? Here you can see that we check request.path to see that it's fav icon, ICO, and so on, and we return not found for that one. There's actually a slightly better way of doing this, which we will, you know, implement, right? And so here at the end, we will actually find that there's this welcome message send, right? Which is what we do if we don't have any particular path that is being requested. So how that actually looks in practice is, let's see here if I can, undeclared name, yeah, that would make a lot of sense. Handle welcome is a procedure that takes a socket. We said this was a TCP socket, right? This is actually so that every handler should be able to do socket stuff if they want to, right? It also takes the request, right, which is a HTTP request, and then it takes an allocator, which is a MAME allocator, obviously, like this. And here, let's see here if we can, sure, yeah, this looks vaguely correct, right? This looks like what we want, basically. And yeah, we're sending here, so that's fine. I'm going to basically now pull this out here. Actually, let's just do this for now. We're not actually using the routing now, but we're going to basically start using it. The routing now is not involved in this now, but we are delivering this payload, right? That is coming from the code that already exists. Now, if I basically say this code here will do nothing, right? That doesn't exist anymore. Let's see what happens when I do this, right? So we can basically see, oh, our stuff is working. Now it will not work, but we will replace this. Here you can see, oh, we're not handling anything anymore. We're now sitting here spinning, doing nothing, right? That's because I removed the code that sent this welcome message, right? So what we will do instead now is we will basically comment this out, this entire thing. That is just a massive piece of shit. This is so much. God damn. There you go. Now we have nothing, right? So what we actually want to do now is, this is in handle client, right? For every client, we actually want to do something with a request, right? So we parse a request here. Now we have a request here. Why is OLS complaining? Oof, okay. So this is the request. Here we have a request, right? And now we want to actually route this to somewhere, right? And what we can do here is basically we can say handler is equal to server get handler, like this, right? And we pass the server to this and the request that we have, right? And remember, this code is going in and saying for every server handler, registered handler, right? I want to run the matcher that is associated with that and see if I should return this handler, right? And if we get nil, if handler is equal to nil, we want to do something, right? And here, what I'm going to say is handler is equal to handle 404, right? And that will be a function, much like our handle welcome, right? And hopefully Copilot is smart enough to understand here. Yes, yes it is. So handle 404 will obviously take a socket, request, an allocator, etc., and do this with, you know, those things. I feel like there should be a, yeah, no, never mind, it doesn't matter, not for the time being at least. Handle welcome here, let's see, should be fine. Indeed it is. I'm just gonna make this slightly shorter like this, and then we basically we should now have, let me just double check this. So now we have registered this handler on our server structure, right? This server here, we're passing in the handlers associated with the server. We are going to have to say server handlers equals make registered handler. We can do 0, 0 here, and we can just say context allocator, that's fine. It wouldn't really matter, to be honest, that much. Now we have this structure here, right? We have basically this dynamic, which we should have, right? Dynamic array. The pointer to this, or the information therein, is then being passed to our clients. He said before checking, client state, right, I have made a small mistake here. Handlers is what we want. And this is of course server handlers. Now the threads will have access to this information, right? Let me just double check so I'm not missing anything in the chat. Very sorry. What server are you writing, by the way? Jishon. Actually, how do you say your nickname? Welcome message declare but not used. We can kindly tell that to fuck off. And here we have server get handler undeclared name server. Right. We can in fact say get handler. This is no longer effectively a method on server. It's actually a it's just going to take the registered handlers, right? Because it doesn't actually matter. We don't need the rest of the server's data here. So now we don't say server get handler, we just say get handler, and then we say handlers, for example, like this, state handlers probably, right? This points now to the handlers. It's an awkward one to show up in, I will say that, mostly because it's going to be probably a little bit shorter than the other ones, because I didn't get much sleep last night and I'm feeling very peculiar, let's say. My head is not with me. I'll tell you that much. Let's see here. Now we're not doing shit. Let's see here. Server register handler, and in our client handle client, let's see. Down here we do get handler. Oh. We're never calling the handler. Handler, we're gonna pass the client socket and the request and the allocator. Yeah. So yeah, like I said, my head is not necessarily super with me, to be honest. And now we can see that this actually works, right? So just to kind of, let's step through this kind of, right? Oh, image processing. And image processing, so, are you doing resizing and so on? like you have a service that basically does resizing of images, makes thumbnails and stuff like this. Because this is probably the most common thing, like, hey, I want to introduce a fast, quote unquote, fast language. Yeah, exactly. Okay, so it is exactly that use case. I want to introduce Rust, right? As most people say, like, oh, well, okay, so what can we do that doesn't break anything else? Oh yeah, we have this really awful resizing service that we rely on. We basically do batch processing, right? It's the perfect scenario. I really like this kind of setup. Because it's like, you can't break anything. Well, of course you can. You can always break something, but I mean, generally you won't, right? So it usually works out really well, I think, in these particular, like these scenarios. I'm much more, I mean, historically, I've just introduced stuff, to be honest. I mean, not in order to break stuff, or we haven't really broken a lot of stuff. But for example, the reason I started using OCaml for work, for production, was simply, actually I will show you guys this because I do like it so much. There was this library called bucklescript T by Overmind L1. I don't know exactly how you're supposed to read his nickname. He's a funny guy, interesting guy. So OCaml, right, is of course, like, at this point we all know what I think about OCaml. Like, I'm not super enthused, right? But at the same time, you know, it is a fairly beautiful language. I like the language itself. I just really dislike the runtime because it has nothing, right? You compare it to Haskell, OCaml, whatever it might be, it's just so far behind. But bucklescript was a compiler. Nowadays it's called Rescript, ReasonScript, ReasonML, whatever the fuck they're calling it. Doesn't really matter. Same shit, really. Bucklescript was a compiler from OCaml to JavaScript, right? And of course, in JavaScript, we don't have threads, right? It's not even a thing. The runtime itself is about as barren as OCaml. Like, we have no nice things to do, right? We don't have green threads. We don't have anything. We have async. That's basically it, right? And the nice thing about taking OCaml is that it's such a huge step up from anything JavaScript, TypeScript, whatever it might be, right? That, of course, right? It just makes so much sense. It's just a straight up, you know, high quality kind of functional language, right? If you're in this kind of context, because it doesn't matter. Like, oh, you don't have threads? Yeah, we don't have threads in JavaScript anyway. So it's like, whatever, right? And so one of the apps that we had, which was customer facing, which may be why this is even more funny somehow, we actually ended up using the Elm architecture. That's what T stands for here, right? So the Elm architecture, but in OCaml, right? So for those who might not know what Elm is, we're going deep now. So hang on, let's see. For those who might not know what Elm is, it is a language that looks vaguely like Haskell and is only for front-end applications. So let's look at the button example because it's just so simple and straightforward. The thing on the right is what we are rendering here, right? So we get this interactivity, and there are a few key components to this. We have this main function that calls basically whatever sandbox here. It's basically taking an init function, update function, and view function. Hello. I've been programming since 2001, or did you mean now? Like programming now in the evening? Because that's about 30 minutes for now. But yeah. Anyway, so you have this idea that basically you have an initialization function, you have an update function that takes messages, right? And a model. Your model is your state of your app. In Elm, you just do global state, right? And we take a message. Here, the messages can be increment or decrement, right? We could also say, hey, reset, right? And if I actually save this now, let's say I rebuild this, Actually, we can do dark mode. Fuck this. If I rebuild this now, we're gonna actually see here at some point. Let me just enable JavaScript for whatever reason. Let's see here. Fuck the lights. Let's add a reset here, right? Now, actually, what is this question mark? Never mind. Now we're gonna see, oh, hang on, we're not handling reset in our model, right? What should reset do? Well, it should probably just say, you know, 0, right? Our model is an integer, by the way, right? It's an int, right? So when I save now, I rebuild. We need a button for this. Let's see here. Let's throw up a button also. Actually, when we click on the number, let's say when we click on the number, we're gonna reset. On click, reset, right? Let's just rebuild here. Now when I click on the number, we just reset, right? And all I actually had to do was effectively just say there's a message, reset. There's a way to handle that message, right? All of this to say that, so we ended up using buckle script T, right? The Elm architecture in OCaml via buckle script, which is a compiler that takes OCaml, turns it into JavaScript. And we actually used this for a customer facing application that was basically made for them to do some logging in and kind of basic management of their user accounts to some degree, and so on. And it was really nice. So that's how I prefer to introduce stuff. We just shove it in there and we do a good job. as opposed to the image processing server that is sort of the riskless, sensible choice instead, right? But I will say this, when you do stuff like this, right, you see a lot of stuff in the end, because, I mean, of course, I think I should add, though, to be clear, when we were doing this, we were far ahead of schedule, right? The entire project, because we were using Elixir and so on in this project, right? We were actually working kind of in tandem with a team that was using Scala. And the Scala team was constantly way behind schedule. We were way ahead of schedule. So to a large degree, we could experiment with things that were a little bit, you know, risky, right? And so OCaml kind of, you know, and it turned out really well. Like OCaml is a fantastic language for writing JavaScript web apps. I will say that. It is really, really good for this. Because again, OCaml really, the worst thing about OCaml is it's just such a 90s kind of runtime. Like you don't have any nice things like green threads or stuff like this. But does that matter when you're executing JavaScript? It really doesn't. Love to India, by the way. For those who might not know what I mean by this, Amit was saying love from India. I'm from Sweden, but I live in Bulgaria. Oh, risky. Nah, not that kind of risky. You know, with memory. No, C++ is actually not a very risky choice. But yeah, so OCaml was the risky choice because it was like, oh, what do we do? We actually ended up replacing that project with TypeScript, which I will say broadly speaking, this was a mistake after, certainly. But at the time it seemed sensible, to be honest. But I think it was a mistake because, well, I mean, as much as possible, we just re-implemented the Elm architecture in TypeScript, so it was slightly worse. And normal React projects are fucking awful. So I would never, honestly, you couldn't pay me enough to work on a React project built by React people, to be honest. At least if we're gonna work on React, let's have it be built by people who don't actually like React, you know, because they will have much more sensible, you know, choices. They're gonna generally be a little bit more like, you know, I don't think we need 5 layers of components here. I don't think we need a bunch of stuff. You know, we don't need to import every package from npm to do these things. But yeah, right, I got sidetracked. Like I said, I'm not fully 100% today. Anyway, so, okay, let's go over what we've done, right? Because, exactly, yes. I mean, if you're gonna do JS, just do it a sensible way, to be honest, right? There are ways to actually do it that are more sensible than others. For example, use OCaml. That's it. Honestly, it's way better than actually writing JavaScript. If you're writing a front-end app, you might actually use Elm. So yeah, just the context for this LSA was that I was talking about how you can have different ways of introducing projects in your code bases and so on, or languages, right? Because Jishan has been working on a very sensible image scaling kind of service in Odin and so on. He was introducing it there because that's obviously fairly safe. It's a reasonable choice for introducing one of these quicker languages and so on. And I was saying that we just sort of went Rambo and introduced OCaml into as a user-facing application for writing JavaScript applications instead, because that's the kind of not sensible choice that I like to make instead. So anyway, I keep getting sidetracked. Let's focus. We have these handlers now. So I made the server structure, which can contain more than this right now, but we have these handlers, right? So what is a registered handler? Registered handler is just a combination of a matcher and a handler. What is a matcher? Well, it's a thing that takes a request and says, I can handle this request, right? That's a matcher. The actual handler is basically the function that takes the socket, it takes a request, and it takes an allocator and actually processes this request, right? So when we register a handler, we're basically saying, insert this matcher here and this handler together. And when we get the handler for our server, right, we actually say for every handler in this server or this list, this dynamic array, right, go and check if the matcher, which of course returns true or false, does that handle this request? If it does, return the handler, right? And remember, a handler here is just basically a function pointer, right? You can see up here, it's this one, right? Not quite. It's really just kind of a fairly low effort lookup table based on predicates, right? Because the predicate here is the matcher, right? The predicate is basically saying, yeah, I can deal with this, or no, I cannot deal with this, right? And the first one to say yes gets the request, right? But in some ways you could maybe see this, right? And so the idea here is that we set up this dynamic array of registered handlers, right? And then we say basically, we add our first handler, which is if you get a slash here, like this, right? So this is our matcher. We're saying if the path is equal to slash, that is going to return true, right? And if that's true, we're going to go down to handle welcome, right? And that is this hello world handler, right? So what happens if we don't find anything, right? Let's go to the actual usage here. For every client, when we have parsed our request, this request here, what we actually do is we call getHandler, which of course returns a handler, which is a function pointer, which can be nil. And we do get nil when we don't find the handler, right? So if the handler is nil, we're going to set that handler to handle 404, right? Because that's not actually known, right? And then we're going to call the handler, right? So let's see what actually happens when we go to a site that, or a slash rather, a path that doesn't exist. We get 404, right? We don't have any information in this 404, but that is what we get, right? So we have a fallback. basically. Hello, Mnai. Wow, that is quite the name. How do you say this? Mnai? Mnai? Oh, here's my to-do, by the way. Support something like the below. Fuck that. We've already done that. So now we want to actually set up our WebSocket handler. And that is an interesting proposition, right? Because we actually want a second handler to be registered here. And that's going to happen in our main function, actually. Up here. And here we want server register handler, like this. Take the pointer to the server because we're modifying it, right? And /ws, this is for WebSocket, handle WebSocket, bam, right? Now we have to create handle WebSocket, which is going to be, let's just put that here, a proc that of course takes the same things as we have from before, a socket, Copilot is not agreeing with me here, a request, which is HTTP request, and an allocator, which is a mem allocator, like this, right? And here we're gonna handle stuff, right? In here, right? And we are going to basically, we're just gonna straight up copy everything here, I think. And this is a handler basically for the entire WebSocket thing. We may have a syntax error or 15 here, but it's gonna be fine. We're gonna deal with it. 12 errors. Break only allowed in non-inline loops. That's, I suppose, fine. Let's say return there instead. A return here, perhaps. A return here. Return here, perhaps. And a return, maybe. Slap a return on that bad boy. Let's say break there, probably. Client socket is not really what this is called anymore. Ooh, where are we now? I have just gone somewhere. Socket. Oh, no. That's not, that wasn't correct. Let's see. Have you registered in ChatGPT? Oh, hang on, there's so much here. I like a little application of sorting that sorts all to-dos on a project and sorts OOOs? What's OOOs? What does have you registered in ChatGPT mean in this context? I do have, I mean, I have access to ChatGPT, yeah. Oh, okay. Yeah, what I have for these things is to-do comments here. So for example, I have this. I can find to-dos and notes and stuff like this. But yeah, I don't have any special sorting though, I will say. I do have a little bit, for example, search to do and fix, right? So I can search for only to do and fix. If I'm working on something, for example, the whole day, I'll generally speaking be making the to-dos as I go, right? And then I can be like, oh, hang on, I had a to-do for this thing, and then I can, you know, find that particular to-do and so on. Host header declared but not used. Oh yeah, right. That makes perfect sense actually. We're not using it at all. We don't need it. Undeclared name, receive buffer. Yeah, I think we can actually slap that bad boy. I have that Pavo up here. Yeah, let's just do that. Let's just make this the biggest of the boys. Let's just do this. Issues from to-dos. Yeah, I don't think that's, I mean, it's not kind of what I'm looking for, to be honest. Generally speaking, I would say. Remaining data declared but not used, I think we can kind of tell that to fuck off. Yeah, this is actually fine. Now we basically have the WebSocket handler as well. Now, we might check if this actually works. To be honest, I just kind of git stashed this whole project before we started, so I'll be I have no concept of whether this actually works or not at the moment, to be honest. So we're gonna just sort of go. Now I'm starting the server here, and we are going to start our favorite testing thing, WebSoCat. Right, so WebSoCat here, we're gonna turn on extra verbosity, VV, and we're gonna send, I'm not gonna send binary messages, that doesn't make a difference, to be honest. Now we connect here, and you can see that it says connected to WebSocket, right? And we can say hello, like this. And here we can say that, we can see that we receive text data, hello. And everything seems to work, right? So our routing is working, right? And again, to re-emphasize, right? This handle client function now is completely agnostic to the actual handling of what's happening, right? The only thing it does is parse a request, right? It gets a handler from the registered handlers, right? And then calls that handler on the actual request, right? And the thing we do up here is basically just we register predicates that say take a request and return whether you actually process this request, right? And so for WS here we can see, oh, this works, right? We saw that /WS, this worked, right? And of course we can ask other questions about the request here. A request contains many things. It contains a method, path, protocol, and headers, right? So we can use more information here. We've just gone for the simpler option here of just saying, just check that it's /WS, right? And so on. And so, yeah, this routing now works. And of course, you could imagine you could build this here, right? So you could actually say, hey, we can basically build this structure, right? From something else, from a file, from a JSON file, for example. Perhaps, right? It's not very hard to do, to be honest. Right? You could imagine, for example, a scenario where we had, for example, oh, we have a JSON file with path is this, for example, that automatically generates a function that checks for path is equal to this, right? Or whatever, right? And then we might have, for example, a name of a function. That function is going to be pulled from a dynamic library, for example, right? So in the JSON file, it will actually say handle welcome in strings or in quotes, right? And so on. The world is your oyster, right? You can do whatever you want here. Personally, I'll just do this. It's a lot easier. You have just normal code, right? You have simply a function that says yes or no. You can use whatever information you want in here. You know, it doesn't matter. You have a normal function pointer you can point to, right? And so on. But yeah, I mean, this is basically what, effectively, this is what the actual episode or the actual live stream was going to be about. And we've done it. It seems to work, right? It works fine. And to be honest, I was fairly certain it would work because this is very high level, right? And this is something actually that in some ways I think people ignore a little bit. When you're doing stuff like this is trivial stuff, right? And And this is kind of what we compare sometimes to, I feel, when we compare, for example, oh yeah, I implemented this gnarly algorithm, or I learned a new concept and implemented it in, for example, a language, right, in Zig or Odin, for example, right? They compare that to, oh, I set up a web server via a framework in Elixir or JavaScript, right? And these are not quite the same, right? This logic is easy in any language, right? It's just trivial in the end. We've built a very simple lookup table that works with predicates, right? It's not really a lookup table. It just goes through the handlers and asks, do you want to handle this request, right? And so on. And that's it, really, right? It's not very hard, this kind of stuff, right? It was, of course, definitely harder implementing the actual protocols in question, right? Both HTTP and WebSocket stuff, right? So yeah, I wanted this particular live stream to be a little bit more, less involved, because I haven't slept last night and so on. So yeah, I think we're kind of good. Now, I want all of you to tell me what the rarest language you have used apart from Odin is. Because I really like this conversation about using rare languages. Like Jishun was using Odin for this image scaling service, and so on. By the way, how is this actually working out, Jishun? If you're still here. Oh no, everything is implemented. There are no dependencies, Chimekis. So what that actually means in practice is not that I've implemented all of HTTP, right? But what that means, for example, is that we have code that deals with parsing a request and so on, right? Like this. And this is based on a tokenizer that I have also written. And it's really just doing basic parsing, right? HTTP is just text. There's nothing, no more actually to it. We also parse responses because we have an HTTP client, obviously, which is actually the easier of the two, really. And so on. Oh, we or Wewa, I think it's pronounced. An array language, a stack-based array language. Very interesting, indeed. For those who might not know what that means, I present to you one of the most elegant languages ever made, APL, which stands for a programming language. Like, how cool is this, right? So APL is old. APL is from '66, right? And is an array-based language, which basically means it deals extremely well with everything that is an array or an array of arrays or whatever. And we're going to scroll down very carefully here so we don't, go crazy. So how APL actually looks is based on keyboards that kind of look like this and so on. And you see these icons here, right? They are Unicode icons that stand for different things and so on. And this is actually the syntax of APL. So if we can find this. Oh my lord, why would they do this to the article of APL? Let's see, APL example code. I'm gonna show you some stuff. This is beautiful. Oh, Haxi. Yeah, no, it's fairly rare, I would say. I mean, Haxi is certainly not mainstream, right? Basically, I'm saying, yeah, and I did say rarest, right? And for someone, the rarest language they've used is Java, right? And that's fine, right? you know, so I don't mean like, oh, give me something spicy, you know. Certainly what we're looking right now at is definitely spicy, right? So APL is an array-based language, right? This here is an array, right? 1, 2, 3, 4, 5, 6, right? This here is a function that actually takes another function and applies it to the whole array, right? This is reduce, I think. If we had, they don't like calling it a reduce, to be fair. Just putting it out there. They really dislike when you do that. But I don't remember what it's called, so whatever. And so code in APL is really just a sequence of applications to an array that comes from both right side and left side, effectively. It is, I can't read it. I mean, I've tried a few times, and I've written some kind of basic calculation stuff for calculating like schedule stuff and so on, but you know, nothing real. But I do like it a lot. It's interesting, right? Oh, you started learning PHP. I'm sorry for your loss. No, but why are we learning PHP? I mean, PHP is not nearly as bad as it used to be, I'll tell you this. Oh yeah, BQN is also... Yeah, there are so many new ones. Like, for example, I like J. So J APL, like, I'm gonna search. J is one of those terrible names. You can't actually search for it, to be honest. Like J Lang, maybe. J programming language, right? So it's basically APL, but it's expressed in ASCII instead, right? And stuff like this. But it also has a little bit more of a, let's say, if you like functional programming and tacit functional programming, this tacit programming here, which also is called point-free, right? So point-free Haskell programming has a lot in common with J in how it kind of works, except it's much, much more advanced and interesting in J. It's just really weird as fuck, but yeah. Yeah, this is a good example of tacit Haskell code, yeah. Try learn Lisp for fun and profit. Not profit, but we'll give you some sparks. Yeah, I do recommend. I mean, I think everyone ought to use Lisp a little bit. You know, but that's... I was, for a few years, I used Racket Lang, which is a language for building languages, basically, and using those languages to solve problems. So you can see here that you have different languages you can specify at the top of a file, which basically is just it's new syntax that does stuff. Racket is a fantastic environment, by the way. It's just sort of, it makes me feel good inside. Honestly, I wouldn't use it for any production code nowadays, but you know, it's there. It's just a nice language for doing stuff in, to be honest. It also has one of the nicest GUI languages that I have ever used, actually. Yeah, Canron or Mini Canron, yeah. This is a logic language. Let's say Mini Canron. If I remember correctly, it's a logic language. Relational programming, basically relational logic. This web page was not super. So basically, actually in Clojure, you can actually execute stuff that is sort of like this, if I remember correctly. Maybe you can't. I seem to remember they had some kind of Canron mode you could turn on in Clojure, where you could basically execute mini Canron stuff. Is it created by, because let's see actually also mini Canron. Let's see. Wow. Because Will Bird, as far as I know at least, he was not part of creating Scheme. If anything, I think he's actually too young for that, right? So if you go to Scheme, this should be Rick Steele. Let's see here. Yeah. Guy Steele and Jay Sussman. Gerald J. Sussman. They also wrote Sickpea, if you know this book. When you say created using macro, I mean, Scheme is all macros basically. Because Scheme is basically a very, very small set of core forms, and then everything is built by expanding to those core forms. That's it. But again, it was Guy Steele and Gerald Sussman that designed Scheme. I mean, of course, that maybe Dan Friedman also was involved. I don't know. But certainly those are the two you would expect to be here. Hang on. Let's see here. This one, presumably. I have to say it's odd to see someone capitalizing macros like this. I feel weird about this, to be honest. It looks, for how much you're talking about Scheme, it looks way too much like Common Lisp. Because this is how they write stuff. Macros. I don't understand. This is Common Lisp code to me. It looks basically like this. They're yelling half of this stuff, and it doesn't matter because they don't even have, it doesn't matter in their language basically, or whatever, sometimes. Perf-oriented Lisps. One of the most important for this is actually Chase Scheme. So Chase Scheme was created by Cisco, if I remember correctly. Let's see. Developer cadence research. I want to probably find here that Cisco open source Chase Scheme in 2016. It was purchased by Cisco in 2011. But yeah, so Chase Scheme is one of the fastest schemes. And then you actually have a scheme called Stalin. And of course now I got to Stalin like this. Let's see, disambiguation. So that's obviously a Stalin scheme implementation. There you go. So Stalin actually became fast because it compiled everything ahead of time, or it did static analysis ahead of time, right? So static language implementation. So it's a scheme that does stuff, up front. So it actually got some speed like this. And here you can see the name is a joke. Stalin brutally optimizes, right? So that's the thing. You might feel like, hey, that's a little bit insensitive, but yeah, such is the computer science stuff. Anyway, so yeah, Stalin is interesting in this regard. Though I think this hasn't been developed for, quite some time. We can see the 0.11 was 17 years ago. I don't think you'll be using this chase scheme and so on. And they, realized, hey, this backend is actually made for much more kind of production speeds, let's say. And so they switched. I think actually Idris 2 only compiles to chase scheme nowadays. It used to compile to all kinds of languages, and it used to have native output also, I think. But now it compiles only to chase scheme, and it's actually faster than Idris 1, no matter what, basically. Which is interesting. It's quite the jump they made, actually. Yeah. Idris 2 compiles to chase scheme only, I think. I don't know if they have other backends, because of course one of the points of Idris was always you could have a backend in any language, right? So for example, if we go to external backends here, we can see that there's a Dart backend, an Erlang backend, etc., right? But yeah. The name. Yeah, Idris is, it's an interesting name. The guy who made Idris, Edwin Brady, is a very interesting guy as well. I do recommend watching his talk. He's funny. Also very smart, obviously. This guy. He's done some interesting talks on Idris. It's a very interesting language, because you can have types that depend on values and the types of other values and so on and so forth. It's very kind of, it seems to me like the future of statically typed languages, but it's just very hard to use right now. That's it, basically, I would say. But yeah, it's definitely an interesting entry into the world of programming languages. It's also very practical, to be honest. So one of the things that Edwin Brady has always said is that he is not so interested in having a, just a language that is Turing complete, right? So his measurement of, is Idris actually ready for usage? Is it Pac-Man complete? Right? Can you write Pac-Man in Idris? And so that has always been the goal, to make something that actually can run reasonably. It can actually execute. You can prove rules about writing Pac-Man, right? And so it's not good enough to prove rules that aren't practically useful. They also have to be useful for implementing, for example, Pac-Man, right? And so the idea behind Idris and other languages like it is to put more information in the type system, right? So you basically put more guarantees in the type system that are then checked by Idris at compile time, right? So yeah, it's an interesting entry into the world of languages. Like I said, it's very hard to use now, but yeah. Hello, Gansham. Wow, you guys are really stretching my ability to say these names today. Like, we used to have fairly straightforward stuff, like Evan has joined. And now I feel like every name is a challenge, to be honest. But yeah, Idris is interesting. It's just not, like I said, it's not ready for me to use, to be honest. And also, I mean, it's also complicated, right? And that's what makes it, difficult to use, obviously, right? It's just sort of one of those languages that I think you have to put in a lot to use it, to be honest, right? And so on. Let's see here. I'm fairly sure I missed some messages here. Let's see. Da, 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 da. Oh yeah, Evan, you were using Haxi. What did you do in Haxi? Did you make some games and stuff? As far as I understand, Haxi is kind of, it has that kind of niche, right? And Conrad, you were saying PHP. Obviously, you were learning. Your motivation is dying. Somehow we ended up talking about Lisp because of this. I'll be honest, I have no idea who's here right now. But, you know. Well, I think we established that before, right? And it's not a big deal, you know? What is everyone doing with Odin? Do you have any interesting projects that you're working on? Any questions also that might be interesting to ask in a live setting here, where we can kind of show stuff and so on? Because of course, like we've done the thing that I was going to do in this stream. I'm fairly certain that most of the people who were interested in that saw how that was done and so on. Right, we have these handlers, we deal with this. I'm interested actually because if I remember correctly, let's see, I'm scrolling back here a little bit, sorry about that. Chimekes, are you still here? Because you were asking about HTTP and so on, did we implement this? Oh yeah, sure. So Git subtrees and stuff, right? So there are a few things that go into this. One, you have to actually tell the compiler that we have some dependency, right? The thing we would usually do there is basically when we call build. Oh, here we don't have any dependencies, but I'll show anyway, right? So if I have a dependency, right? First of all, we have this build step, right? We have Odin build HTTP server, for example, right? And that, of course, basically just says, take the folder HTTP server and build whatever package is in there, right? There's nothing magical about this, right? But then what I can do is I can say collection, colon, and then I can say, for example, dependencies equals dependencies, right? And the thing that comes last here is the path, right? So this could be, for example, deps, like this, if we wanted it to be, right? So what I get when I do this collection dependencies here, this means that this prefix here is going to be how I import stuff, right? So if we go back to our normal code, this is that prefix, but for core, right? Core is a collection that always exists, right? The only difference between core and this here is that we have to specify this one. Core is always specified, right? It basically exists as a collection for you already. Same with vendor, right? So if I go to packageodinlang.org, we'll see here core library, right? That's the core library collection. And then we have vendor library, where we actually find stuff like OpenGL, Direct3D, and so on and so forth, right? So when I actually want to use something from vendor, I write vendor colon something, right? That is a collection. That is all that it is, right? So here I can say deps is located in deps, for example, right? That's step one. We have now, this is the folder that we actually want to use, right? And so if I want to do this here, I can say git subtree add, right? So here's how I added IM GUI to one of my projects, right? So let's look at this, you know, piece by piece, right? Git subtree add, and then I say prefix, then the folder I want to put it in. In our case, we said deps, right? Deps, right? That's the folder. I want to squash this because otherwise we get the whole history of the repo, and we don't want that, right? So we want to squash this, which means we're going to have 2 commits when we run this command. That's it, right? And then we have the URL to the repo, right? Nothing super strange about this. And then the branch we're going to use, right? This is going to add that dependency to our repo. So just to illustrate this in a different context, right? So code, Odin, sandbox. If I go to this folder here, we will find, in fact, that we have dependencies in this repo. This one here. Odin build, sgrep, etc. collection dependencies equals dependencies. So if I go to sgrep, right, we'll see here that I import with dependencies :CLI, right? And here is the actual repo of that. This comment is not needed. You don't need this at all, just to be clear. So if I check how did I add this code, right? Well, I ran git subtree. Git subtree like this, right? Same story as before, right? Nothing super crazy, right? We have git subtree add. We say the prefix is dependencies because that's how I specified this collection in this particular case, right? And the folder there will be CLI, right? We squash, of course, we don't want the whole history of CLI. We just want to squash it down into 1 commit or 2 commits rather. And then here's the actual repo of the dependency, right? Oh yeah, when we update, let's see here if I can find this. You can do pull here, for example, right? Some of these are going to be wrong. I'm going to straight up just say that some of these are fucking just don't work, but this one should be correct. Git subtree, no, not really. Git subtree pull, I want to say, probably. Yeah, this one should probably be fine. I mean, we can try it, to be honest, right? I have a new version of this. So let's try this. Deps CLI does not appear to be a git. Oh, hang on. Does not appear to be a git repository. Hang on. Git subtree. I want to see here that we are. We're doing this correctly, because I don't want to show something that won't work, of course. Maybe we can do this one, I'm not sure. I should have a version 8 out. Yeah, okay, hang on. Let's see this one. So now you can see here that I have pulled dependency CLI, right? And we can see that I have new changes here from that dependencies, or that dependency rather. It should basically go into that and pull what it needs to. If we actually go into dependencies CLI, we should actually have a normal git log, effectively, in the end. Let's see here, actually, if we do git status. But yeah, it's basically vendoring. You're absolutely right. It's just a better version of Git submodules, right? Because Git submodules basically, they basically, like, you have to have a bunch of special stuff for them, right? And you don't get them unless you ask for them. You have to recursively do this and so on. I actually do this in a video already, but you are not the first person to ask if I can show this. The video I'm talking about is probably not very popular. Let's see here. Actually, let's just go here to YouTube, blah, my channel, hello. There you go. Playlists. Odin. It's one of the first videos, I want to say. Let me find it. No, it's not one of the first videos. It's this one. Command line arguments and dependencies in Odin, right? And in this video, I showed the steps that I was showing now.
And that's only for error handling purposes.
We actually work on this sgrep stuff, right?
Let's go to our task file and just
show here.
sgrep. Is a distinct.
Because here we're not using a dependency yet.
Arguments. Here real quick.
And here I'm running git subtree add, right? So here we're running git subtree add. That was version 04, of course, but you know. And then we add the collection after this. We also added to OLS, by the way, I should say.
Like this.
You add to your OLS file name dependencies, path dependencies, and so on. Oh yeah, no. I'm not saying, oh, why haven't you watched this video if you're asking about this. That's not what I'm saying. Like I said, you're not the only person to ask for this. So I don't think that this video necessarily has been found by everyone, right? Yeah, that's it. I know people who have watched all of the videos, but basically either have forgotten or maybe they weren't paying attention when they watched this video, and that's fine. I'm just saying it's in there, right? So if you do want to look at it, I might make another video trying to, you know, make that clearer, perhaps, because currently it's kind of, maybe it's not working that much to have this video, right? It's not as clear as people need it to be, right? But yeah, so these steps that I showed, we actually show these here in the video at least. And if you really do need, like, hey, I need to know more, git subtree has documentation, of course, right? You know, it's not an Odin thing. It's really just git stuff, right? So if you're really interested in that, you can also go, you know, deep and learn more about it. I've learned as much as I need to know, and that's basically it, right? Those two commands, basically, adding a dependency and updating it, right? Because that's where we actually spend most of our time in the end, right? We want to update the dependency that we have. We actually want to add it from the beginning and so on, right? And then thankfully, I don't really do this often enough to have any other exotic problems, right? Because you could have that, right? But yeah, so yeah, this is how you can do this. And it works as long as you just have an Odin repository on the other side, of course. You can use this for other dependencies as well. Like, let's say you have C++ dependencies in your project. I feel bad for you if you do, but you know, it happens. And that's also something you can do, right? But yeah, it's actually very nice to use a language where you can actually get by doing this, to be honest. Most languages is like, oh no, they need a dependency manager, right? Otherwise we're fucked, to be honest. And Odin is very much not that, right? It's definitely fine to not have a dependency manager, to be honest. But yeah, so with regards to HTTP, we did actually implement all of this. And I guess you were asking mostly because of this, you know, if you're using a dependency, how was I using it? And of course, we aren't using any dependencies for the HTTP stuff. Mostly this is because, well, I just wanted to implement all of this stuff, right? Actually, I kind of like using software that I've made more than anything else, to be honest. So, I just really don't like dependencies in general, to be honest. But I do like depending on my own things, to be clear. Right? So, in the case of Odin CLI, I wrote that, right? So, mostly though with IMGUI, that is L4, a project made by a guy called L4, right? He made bindings from Odin to IMGUI and so on. So we're using that partly because I told him I would try it out and see if I could teach that to people and so on. Yeah. I will say that I don't think that this particular way of doing stuff scales, right? Because you need a dependency manager when basically, oh, we have 5 libraries. Some of them depend on the version of the same library. Some of them have a different version of that library, and so on and so forth, right? So, like you're saying, nesting and you know, stuff like this. Yeah, I don't think the Odin model of doing stuff like this necessarily scales particularly well. But I will say this: if they use Git subtrees, it will actually just pull their subtrees without you saying anything. So it will work, probably, as far as I understand, right? Because if you git pull my projects and they have this Git subtree, you don't actually have to do anything like special. You just get the dependency. So it is pure vendoring. It's as if we just put the folder in there, right? Basically. So it's much more this kind of old style, just shove the code in there kind of way, but you're managing it with Git still. So it's a little bit best of both worlds kind of situation, but you know, again, like you're saying, I don't know that it scales very well. And it doesn't have to scale, right? Because, well, it depends on who you are, I suppose, right? In the end, for someone it does have to scale much better, right? Because they don't like writing their own code or whatever. Maybe they can't write all of the code themselves, and you know, they need, obviously. Yeah, the deps in that is an interesting question, right? I suppose the collections are gonna be the worst part of that. I'm not sure actually, yeah. Yeah, I mean, yeah, I guess, I don't know. It's very difficult to talk about this without sounding like, you know, because it's not a new concept to not have dependencies, right? It's also not a new concept to have a ton of dependencies, to be honest, right? So if we look at the entire Linux ecosystem, it's just a series of massive dependencies, right? This is the entire problem of the Linux ecosystem is dependencies, right? That's why every distro, every distribution has its own package manager and all of this nonsense, right? It's because no one ships their dependencies and they depend on 1,000 things, right? Because this is not a new problem. They've always been like this, and dependencies have always been shit, right? Yeah, shared libraries, right? Linux people love shared libraries for no reason, right? Just share libraries, the whole system. Someone upgrades that library and now 5 programs might be completely destroyed and they don't even work anymore, right? But for Linux people, that's like, yes, I love it. You know, oh, apps are breaking. But it doesn't make any sense. Like, it's just stupid, right? If you compare this to, you install a game from 2005 or whatever, 2001 on Windows, there's a good chance that game just works, right? Or applications. You install Winamp 2.5 or 2.7, for example, and it works, right? Winamp, they're fucking mega old, right? because yeah, in the Windows kind of ecosystem, they just don't think like this. Yeah, static linking has become a lot more common, and I think in no small part due to, in some part, Go popularized this to some degree, and then Zig certainly takes it to another degree, right? Zig doesn't, you can compile basically with muscle libc, so you can statically link libc as well, right? And Rust obviously is leaning more towards static linking and so on. In fact, they don't want to support anything else, as far as I understand, and so on. But I think Zig really gets it right, because of course Zig can have dynamic stuff. There's no question about that. But they basically say, we ship libc if you want to statically compile libc as well. So you can basically just say, I'm going to distribute a binary with all of the libc calls actually compiled into it that I'm using, right? Which means someone can be on the oldest libc known to man. It doesn't matter. The code is actually just in the binary, right? And this is amazing, right? You can just deliver this, right? But yeah, like you're saying though, Chimek, of course, some libraries, we want to share them, right? Because if we get a security update for those libraries, yeah, it would be nice to just get the security update, right? Absolutely. These are very few though, to be clear, right? There was a good article by Drew DeVault on this. So Drew DeVault is a bit of a figure, you could say. Let's see here if I can actually... this is not about the Odin project. The Odin project is a web developer thing. This is about the Odin programming language, which is not the same, not quite the same. In fact, I'm not doing web development. I'm writing a web server from scratch. So you could say I'm doing I'm doing web development. I'm just developing from the ground up. So yeah, it's not quite the same. You're thinking about the Odin project, which is the, let's see here. Let's see. Can we open this page? There you go. Oh no. Oh yeah, yes. Our full stack curriculum is free and supported by a passionate... Yeah, this is the Odin project, right? This is a different project. They're teaching these things, right? So we're not talking about that. We're talking about a programming language called the Odin programming language. You can find this on odin-lang.org. And it's not quite going to do what you're looking for, but you can make the things instead that those things are using or doing. So, give me a month or so and I'll have a few of these solved for you in my web server. No, actually, HTML and CSS, easy peasy. We're just going to serve some files. We're not going to use React. We're going to use HTMX instead, right? So I want to introduce to you our Lord and Savior, htmx.org. And so HTMX is basically, you can include it like this. You just include this script. What this script does is effectively goes through your HTML and attaches handlers to everything that has, for example, hxpost and so on here. And what that actually will do for us is that it will give us interactivity by basically sending a request to our web server that basically sends back HTML, and then HTMX inserts that HTML into our page. So that's how we get interactivity. We don't need a massive framework. We just need something that sends basically does a normal GET request or a POST request and gets HTML back, exactly like a browser should, you know, and that's cool, right? And so we can actually do that. And also I do want to because I think it's one of the best things about HTMX, in fact. My connection is a little bit off, maybe. So HTMX has this excellent meme section that I really like as well. Oh, hello. Hello, Vishnu and Harsh. I have to ask, are you here for the Odin project? Because I've learned now that maybe a fair amount of you are actually interested in the Odin project, and that is not necessarily what we're talking about on the stream. I'm very sorry. I'm very, very sorry about maybe the confusing. So we're talking about the Odin programming language on the stream right now. And that is not quite the same. So you're looking for this, the Odin project, right? And that is about learning web development and so on, right? We're not necessarily talking about this. I wish you the best of luck, right, with doing that though, because, you know, yeah, it's an interesting field. I've worked with web development and so on for quite some time. But we're talking about the Odin programming language, which is this fantastic joy of a language. Look at this. If we go to the overview, look at this beautiful syntax, huh? Aren't you interested? Don't you feel this is where you want to be? Yeah, numbers and variables and all kinds of stuff. We have it all. Yes, yes, that is the enthusiasm I need. Okay, we have it. This is what we're doing with our life. Harsh and Vishnu, we're writing Odin. We're gonna write some Odin. If you want to learn some programming, I know this guy who makes these videos. Hang on. I'm just gonna find them. So I'm gonna paste this guy's playlist. He's a little bit boring, but you will learn. You will learn some stuff, I'm pretty sure. If you go through this playlist, I think you can actually learn a fair amount about computers and so on, how they work. You know, I think it will be useful. No, but to be honest, that is why the playlist is made, to be clear. So if you do actually want to learn programming, I do think it's a sensible thing to do. But if you want to learn kind of something fundamental that has a market out there, and still will teach you these things, Odin is a very small language. It's not very popular, but if you want to learn a very popular language, which does teach you these things, there are two main choices you can actually go with. I would say you can learn C, C programming language, right? This is a reasonable book just for getting introduced to doing things and so on, if you want to do this. I'm sure though that there are tons of resources out there that you can actually go and learn C. The reason I think that you can benefit from learning C is that for the most part, C will teach you about how to think about what actually happens inside of the machine when things are happening. So, for example, this course here is going to teach you Ruby and databases and Ruby on Rails and so on, and that's cool, absolutely, right? But what does it mean, for example, to actually have a web server respond to something, right? Well, it's doing this via something called sockets, right? What is a socket? socket? Well, it's a network connection. So when I go to the odinproject.com, right, if I show you here in the network here, we can see here that there is a request, right? What actually happens when that request happens, right? Well, what we're doing is we are going to be connecting. Holy shit, can I just move this? Okay, apparently not. Never mind. We're going to connect to www.theodinproject.com, right? This is a machine on the internet. Our computer is going to say, what is the IP address of that machine? It's going to ask what's known as a DNS server, right? And it asks this DNS server, hey, what is the IP address of this? An IP address is a mostly unique address on the internet that says basically, here's the number where you can actually contact this machine. Then we are going to connect to that machine, right? We're going to connect, in this case, on port 443. And that is because you can see here, HTTPS is what this is saying here, up here, right? HTTPS. If this said HTTP, we would connect on port 80. This is just a convention. This is just how it is. On HTTPS, right, we connect to 443. We do a little bit of talking back and forth to establish what is the secret kind of language we are going to be using between ourselves in order to send information. That's not material to what we're doing now, but no matter, right? Then what actually happens is we request some information, right? If I look at this GET request here, we can actually look at the raw form instead. If I can find the raw form of the request itself. We are going to ask for /. This means the index file, right? The front page, you can view this as, right? We're going to ask this in a certain way. Let's see if I can find this here. Request headers, here we go. Or request. Yeah, so here you can see, I'm gonna copy this information. We're gonna put it in a file so we can read this shit. I'm gonna just make this like this now, and we're gonna go through it, right? The first thing we're sending to this web server is we're saying, I wanna get a page. A get is simply, send me some info. That's what we're saying, right? So that's it. And like I said before, we're looking for /, right? So we're looking for /, which is the index file. And then we're saying, by the way, I'm speaking HTTP 1.1. This is a protocol, right? So this is a mutual understanding between us and the odinproject.com, right? Here is the way we are going to communicate with each other, right? We're gonna say these things to each other, right? This way, right? So the protocol is basically how do we express these things. Then what we're saying is we're sending these values to the other server to basically tell the server, hey, here's what I am expecting from you. For example, we can see here that we're sending accept text HTML, application XHTML, and so on. What this line here means is that our browser is saying, here are the formats that I actually handle, right? So if you send me these, I can work with that, right? Okay, Harsh, good to know that this actually worked. So basically, this is how we're saying when this line is sent, right here, this one, we're saying, if you respond with this stuff, I can handle that. I can render this, right? I can show this to my user because that's what the browser is for. And then we have accept language, which is of course useful if you want to translate web pages automatically and so on, right? Do we still have Vishnu with us? Maybe, maybe not. Hopefully. I think we lost Vishnu, guys. I think we lost Vishnu, but we gained Harsh. So All is not lost. Yeah, I, yeah, I don't think they were quite in the right place. Maybe, but you know, I do think actually the Odin project. Obviously, it's not the first time I see the Odin project. It happens quite frequently that someone actually comes to the Odin Discord, and they're there for the Odin project, and they paste some JavaScript, for example, they need help with, and usually they get help, but usually they get the help, but everyone's like, by the way, this is for the Odin programming language, so you're not quite in the right place, and then they, you know, say here's where you need it to be, and this is their Discord, and so on, and so on. But yeah, it happens quite frequently. I've seen it happen at least 3 times, I think so. It's a very popular project. The Odin project is very popular in comparison to the Odin programming language. This is actually why my videos, if we open a random video, right? Let's see here. You can see here, in this video I go over some of the tools we have for writing object-oriented code in the Odin programming language. I'm very specific about this, because I need people to understand, like, you know, you've probably ended up in the wrong place if you're here for something else, right? And so on. But yeah. Anyway, I think we're done, to be honest. We had some fun. We did the thing we came to do, of course, like the actual server stuff. I should probably just highlight this again. We have these handlers. We add registered handlers, which is really just a matcher and a handler. A matcher is a way to say, I handle this request. And when we actually add these, the way it looks is like this, right? So we say here, if the path is just slash, I want this to go to handle welcome, right? And handle welcome here is just a function that takes a socket, a request, an allocator, and sends the actual request, right? Yeah, what do you mean? Nice language to work with, or work on. I mean, I think so, yeah. It's my favorite language for sure. I mean, there are things I don't like about it, but there's no language I like everything about. There never will be. But I mean, there are very small things that I dislike about Odin. Everything else, no. It is definitely the kind of language I want to be using, for sure. And I'm very picky with languages, trust me. I've used so many languages at this point, you know, for different things, and I would say my main realization overall is the stuff that people think is important with a language is usually not the stuff that's important, to be honest. They think, for example, like, oh, I need a way to write functions easier. I need closures, for example. I need a way to automatically do this. I need a way to automatically generate code, for example, right? This is a thing a lot of people want, right? We need macros. We need meta programming and stuff like this, right? What I need is an experience that overwhelmingly makes it easy to debug stuff. That's it. Because there are a few things that matter to me when I'm debugging stuff, right? One, I need to understand the fucking code. I can tell you there is Haskell code that I don't fucking understand when it goes wrong, right? That's just sort of how it is, right? And that is a problem, right? Because debugging, we're already in the fucking, like, it's already bad, right? We're already in a bad situation when we're debugging. Maybe it's not so bad, right? Maybe it's not terrible, but whatever. We're having a hard time. That's why we're debugging now, right? So I need a language that actually makes sense when I look at it. It's using basic, simple stuff, right? That's step one, basically. Step two, I need to be able to debug this language. And that means having access to a few things. Having an actual debugger, step number one. There are lots of languages that just don't have a good debugger, right? Basically, they don't have anything you can use to debug, right? Or they have an execution model that makes it very hard to debug. For example, Erlang is a little bit like this, but Erlang makes up for it by having tracing facilities, right? So you can trace your code. You can actually say, give me all of the instances of where this function was called, input and output, for example, right? We can also inspect the state of processes and so on, stuff like this, right? And there's a third one that I don't think people quite appreciate, right? The third step in this entire thing that makes it easier to debug is I need basically to be able to see the data in some raw form, right? Because a lot of the time, my understanding of a problem is such that I need to see the actual data that exists in raw form, so I can say, oh, hang on, that bit there is wrong. I'm seeing this here, I should be seeing that there, right? When I'm implementing, for example, a protocol, right? I need to see the bytes, what they are. I need to be able to connect those byte values to the actual values I'm having in my program, because something is wrong, for example, right? We sent a message on the network that had this information, but I'm seeing fucking garbage, right? If I were to inspect an object, right, some kind of structure in Erlang or in Haskell, what would I see? Fucking nothing. It's just a bunch of pointers to other stuff, right? Because the data is not actually there, basically, right? It's stuff pointing to other stuff all the time, everywhere, right? Because these languages live basically on pointers. It's a pointer to a pointer to a pointer and so on, right? And that makes for much harder debugging, I can tell you, right? Even worse in Haskell, every function is a function pointer. It's a function pointer to a function that takes no arguments and then returns a value, right? That is very hard to debug. Like, this is just, it's tough, you know? And like I said, Erlang is not super easy to debug either, right? But in Odin, I can actually see the raw data. I can draw conclusions from that. I can open a hex editor and see the same data, right? Because it's just a bunch of bytes, right? Everything is just a bunch of bytes. We only make it complicated by using things that make it not a bunch of bytes, right? It's still going to be a bunch of bytes, but now it's a byte. It's 8 bytes that represent a pointer that goes somewhere, right? And so on. It's very difficult. Yeah, I think Odin is very easily used. Ease of use is actually fairly high in Odin, I would say. And it's a simple language also on top. Because I think these are two different things, right? Ease of use is one thing. Simplicity is another, right? And Odin is simple because it doesn't conflate a lot of different things, right? It doesn't inject one concept into another because that's how you're supposed to do stuff, for example, right? For example, it separates allocation from doing things, which is obviously better than having doing things meaning allocation, right? Yeah, the code is readable. And again, this is the reason I need it to be readable and so on is when I'm actually, maybe I fucked something up, right? I'm debugging something. I need the code to be simple at that point. I don't need macros, right? I don't need all of those things. They're only going to make it harder in the end. When people say, like, oh, I need meta programming so I can make a simpler solution. No. Be honest with yourself. And bear in mind, I've used languages with incredibly advanced meta programming facilities. Racket is far beyond what most people have used, right? When it comes to metaprogramming. I can tell you, it doesn't actually work this way. You don't build simpler solutions with these tools. Likewise, you know, there are some people with certain other languages that are like, well, you need a complex language to solve simple problems in a simple way. I don't agree, you know? Yeah, I need something that takes effectively stress away from the debugging session, right? I need a debugger that works, right? And Odin is not quite there, right? We have a debugger. Sometimes it honestly gives me fucking garbage values for stuff. That's bad. At least it just works. It actually goes through the code, right? So fair enough, right? But then I need just to be able to read the code and understand it. Maybe it takes a little bit, but we'll get there for sure. Odin, I have no doubts about. I could read the entire standard library and understand it. It just takes time, right? With some languages, good luck, you know? It's just, no. Especially if they use metaprogramming. And that stuff is different for every repository. How? How are we supposed to work with that? How am I supposed to debug this? You know? Someone makes their own language. I've done it, right? I've done this shit. It's just not good, to be honest. It's just not useful. It's not useful when you're sitting there being like, ah, yeah, stuff is broken. How am I dealing with this, right? I did it on a project where we were always ahead of schedule. And that's the only time I feel like, oh, this kind of makes sense. Because I had time, right? I had tons of time. And I got paid very handsomely for that time, right? But I would never want to be stressed out of my mind trying to debug Elixir macros. It's just not a good recipe, you know, for anything that makes sense. The thing we need is data, we need functions. That's it. And this is why Erlang makes more sense. I'm sorry to everyone who might feel like Elixir is the best thing, but I think Erlang actually can save you time at the end of the day, to be honest. And yeah, macros are difficult on a team level as well, yeah. Definitely. How are the advent of code problems, by the way? I haven't done them, I haven't looked at them yet. Mostly because I'm not super interested usually. But people want me to do them, and I'm not super into the advent of code. Especially, I mean, this is gonna sound very corny, but I feel like it became so mainstream somehow. But yeah, I don't know. Yeah, I think Erlang, the longer a project goes, Erlang is going to be better, I think. And you can use libraries from Elixir, certainly. I don't mind having some Elixir code, but certainly the more Erlang code you have versus Elixir code, the better, generally speaking, I would say. It's just that Erlang kind of, I don't know. It has these things that if you look at them and you compare them to Elixir, right? It is very easy to look at this and say, oh, I think the Erlang version is worse somehow. But again, it's not worse when you're trying to understand stuff, right? It's not worse when you're trying to debug the thing. It's just worse when you're comparing like, oh, here's a macro in Phoenix for defining HTTP handlers, for example, right? That's when it's worse, right? But actually, this is a great time to, okay, I'm on fire today. Rated closure. This is a great time to be complaining about Elixir. I just have to show you guys this. I just have to show you guys this because this just bothers me so much. So we're gonna look at some controllers. Actually, let's go to guides probably. Routing. routing. So it's such a great example. Okay, so here, for those who might not know Elixir, we have a module, right? Def module router, right? This is our project, Hello Web. And here we have this use Hello Web router, right? This is actually a macro. It inserts random code into your module. You're welcome. Let's go, right? Then we have this pipeline here, pipeline browser do. This is also a macro, by the way. It expands to a bunch of stuff. Don't worry about it, right? Then we have this plug here. This is a macro. It expands to a bunch of stuff. Don't worry about it, yeah? These things here are all going to be combined and run one by one when you have pipeline browser. Keep that in mind, right? Here, we have a scope here, right? We have a scope that takes a path, that's our route, right? And then an alias for a project. This is basically just namespacing here. So when you say page controller here, it actually says hello web page controller. Scope here is a macro. Don't worry about it, okay? Here we're gonna say pipe through browser. This is a macro. Don't worry about it, yeah? And then we have get here, which is going to be, specifically for the route slash only, right? We're gonna basically divert a request that comes in on that to page controller here. And then we have the action home that we're specifying. So in the page controller, we will have a function called home that takes a con and some params, right? So that takes a connection. It's basically the thing we did today, except we did it with just procedures, right? Get here is a macro. Don't worry about it, yeah? I'm showing you this only to say every fucking thing here is a macro, yeah? It's basically just a bunch of stuff that inserts random syntax into your module. You would have to actually go and check this to see none of this actually makes sense from any kind of programming perspective. None of these are actually functions at all. It's just a bunch of macros, right? I couldn't pick a better example if I looked for 5 million years than this. It's all macros, right? Garbage. If we look instead to the Clojure community, which also, by the way, has macros, right? And if I wanted to, for example, say, hey, I want to just build some routes, right? Let's look at that, right? Let's see here what we can do. We're gonna pick a more extensive example here, I feel like. I had a good example that I actually built up myself, which I think was a lot more nice than these, but we can yeah, fuck it, we can go with this, yeah? This is only to say that if I, for example, if I wanted a scope in rated, which is a Clojure library, right? Clojure has macros, just like Elixir, really, right? They also like macros, but in rated, for example, we're gonna define a router. This actually is a macro. Okay, we're starting off really badly, right? But what if I want a scope? So remember, we looked here and we said scope here, right? Slash, right? Scope slash. This is a macro. The entire thing is a macro, which takes other macros and expands into functions at the end of the day, right? Here though, well, we just use a vector. A vector here is the array syntax you see here is just vectors. What that actually means is just arrays, right? Basically, dynamically sized arrays, you can say, right? We don't, it's just arrays. Slash API. When I have another vector below that, oh, wouldn't you know, this is a scope now. Right? This is just data. This is data. We don't need to do anything interesting here. And when I say slash ping here, and I have this here, colon ping, this basically says call the ping function on the result, on this request. Pass this, right? It's effectively the same thing we did here, except we didn't have to have any macros. It's all data, right? This just is data. You can generate this if you want. You can generate a vector of vectors. That's all fine. And this is all we're doing here, right? They don't have the actual handlers here, which is unfortunate. Of course, we didn't have the handlers in the other one as well, but we can fit so much more here because we only have data. It's ridiculous. In fact, if we wanted to, we could also say, let me find this. Let's see here. Rated router example. And, because it's so simple, right? Because it's so simple, it also permits very, very simple ways of doing things. So for example, if I wanted to, let's see if I can. If I wanted to, in one of these cases, I could actually put fn here, as in an anonymous function that takes a request and then does something with it. That thing will just return data. It doesn't even do the stuff we were doing. So in our code, we take a socket, right? We take a request and an allocator and so on, right? In the Clojure code, the only thing you get is the request. The thing you return is content. That's it. The only thing you're doing in this router is saying, hey, give me functions that return data and so on, right? They take data, they return data, and the specification itself is just data. This is the absolute worst out of all of these, right? In our example, we don't use any macros, right? We have just, attach basically this function to the handlers, right? And we know the handlers are checked in order. And when we find a handler, we call that handler and so on, right? It's fairly straightforward, to be honest, right? There's no way that you can look at this as a beginner or an intermediate and so on, or just someone new to Phoenix, for example, and know what it's going to do. There's absolutely zero way. It is incomprehensible, effectively, this, right? To anyone who hasn't actually looked into these things, right? And this is a great illustration of the Elixir problem. When you give someone macros, everything becomes a macro. Yeah, the Clojure version is just, if you think about it, the Clojure version is just a protocol. Specify things like this, right? Put an array like this, and it will be interpreted as this, for example, right? In a very simple fashion, right? And then they use other data types to say more things. Here is a map. This is a map with a value or a key and a value, right? That's it, basically. It's very straightforward, this. And so, for example, if we look at this, how they specify this more, path-based routing probably. Name-based routing maybe. These examples are terrible. I found great examples from another source. This is the actual official stuff. Oh yeah, here. If I wanted something more exotic, let's say, right? Here we have, of course, we have this, this is a route, right? /ping goes to ping, the ping function. We can also specify a handler function like this, identity here. If I want something a little bit more exotic, we have this get here, only for the roles admin. This is a map. So when you see curly braces and then some key and some value, that's a map, right? And here we have a map inside of that map and so on. It's all data, right? It's just data. And it's so straightforward, and it's so much better. I can't get past this, that in a world where we have this, we can also have this. And these languages have macros, both of them. It's all about just what's in there, what's in your head. What do you think about software development, right? These people think that somehow everything needs to be, writing the code needs to get so much easier. It needs to be shorter somehow, right? It needs to use custom words to say these things, right? We have to have some kind of idea of what, pipeline. It couldn't be just a list of plugs, for example, right? Interesting, right? Having a list of plugs, which is basically what this is, mind you. When a request comes in with the pipeline browser, right? It's going to go through an accept handler first. This is middleware, right? And we're gonna accept HTML or whatever, right? We're gonna then fetch session values for that request. We're gonna fetch live flash, which is basically messages to show up on the page if you want them to. So you can say, for example, warn the user about something, for example. Then we have this put root layout, which is basically just, it's putting layout content into the request, basically. Protect from forgery, blah, blah, security, blah. Put secure browser headers and so on, right? This is a pipeline that goes from top to bottom. That's all it is. This could have equally just as easily been a list. But when someone thinks, the most difficult thing about programming is somehow writing the code or something like this, they get into a mindset where they start investing time in inventing these kinds of things. We have to have a pipeline keyword and a plug keyword. And then, of course, the pipeline keywords, the scope keyword also has to be able to take a pipe through macro that pipes it through a pipeline that we have defined with our pipeline. You see, like it just never ends, right? And this is not by no means like an advanced router, just to be clear, right? It's just, this is bog standard stuff. But you can see, looking at this, all of this could have been better, right? But it's not. Because it's about what's in here. It's not your language in the end, right? Both of these languages have macros. One of them decided to do this. That's it. It's that simple. Like, it's just so different, right? Because at the end of the day, all that actually matters is, are you the kind of person that actually thinks like this? Because somehow the most important part is just writing the code, right? Or are you maybe this kind of person that says, if everything is data, I can literally run tests on my router. If everything is just data, I can actually generate my router from functions and compose those functions together to generate my router if I so choose. And they're all just functions, debuggable functions, right? They are just straightforward functions that generate some data. And I can test the debuggable functions piece by piece if I so choose, right? Because this was made by people who actually think maybe the hardest thing about writing code is actually maintaining the code and understanding it, right? Understanding the transformations that go into a program instead of writing the router, for example. So with that, I think we should end here, right? Because now I have ranted about this and I feel like, this is a good ending. It was nice having you all here. The stream, of course, went much longer than I expected. But it was nice. It was nice. I'm going to be sleeping a lot tonight, I feel like. So yeah, with that, have a nice day and ciao.